So you want to know what is ZST and ZLT. These are nothing but the sigma level. Z score is nothing but sigma level. Sometimes we call it G score. ZST means short-term sigma level. ZLT means long-term sigma level. If you know any one of the two, the other one can immediately be calculated. Why? Because these two will have a difference of 1.5. If your ZST is, let's say, 6 sigma, then ZLT will be 4.5. If ZLT is, ZST is 6, then ZLT will be 4.5. How much is the difference you are seeing?
1.5.
1.5. Only one of the Z value you should calculate. And again, how this Z value can be calculated? If you really want to know the Z value, either you should have the Dpmo, defects per million opportunity, or you should have CPCPK, or you should have the yield. If any one is known, then sigma level can be calculated, right? But then if it is Dpmo, how to calculate? You have learned from us, isn't it? How to calculate Dpmo, you learned it. Yes. Once Dpmo is known, then there is a table available. You can go to the table and then do it. But I'm going to simplify this job by providing you an Excel template. I have already shared it in the group. Am I right? In the WhatsApp group, I have shared one Excel file that is going to solve this problem, right? So since you raised this question, so let me share that Excel, show that Excel file. So I'm just going the online training. Ninth batch. So here is the sigma level calculator. I'm just opening. Hope you can see the Excel file now. Am I correct?
Yes, sir.
Now, if you have a discrete data situation, you know what is discrete data situation?
Yes.
You are dealing with the defects and defectives. Okay. Dealing with the defects or defectives. Defects means scenario 1 and 2. Defective means scenario 3. Scenario 1 is here, scenario 2 is here, scenario 3 is here. So now let us go to scenario 3. See here, there are 3000 samples you are studying. 3000 samples you are studying. Let me remove all these things. So 3000 samples you are studying here, 3000 samples, and you have noticed 60 defectives. Now can you read the result? Yield is how much?
98%.
Dpmo?
Dpmo 20,000.
And ZLT?
ZLT 2.05.
ZST?
ZST 3.55.
Can you notice a difference of 1.5?
Yes.
Now you got a way to calculate the LT and ST. All that required is this Excel template.
Okay.
Otherwise, you need a comparison table. Manually, you have to search. You have to strain your eye. Don't do all those things. Just type it here and get it.
Okay.
Simple way to get the situation solved, isn't it?
Yes, yes.
Now imagine you have sampled 5,000 units. Sampled 5,000 units.
Yes.
In that 5,000 units, you noticed 65 defects.
Okay.
What is the difference between current scenario and the previous example I told? Previous example was?
The previous example just tells out of 3,000 products, 60 are defective. But here we should also consider the opportunity for error because we are considering the defects in detail.
Very good, very good. You are a green belt, right? See, here 3,000 samples are inspected. 60 items are defectives, means the items got rejected. Here 5,000 samples. You have noticed 65 defects. I don't know how many units rejected, but I only know there are 65 defects,
Okay.
right? So this is a situation too, where the what do you call, the information about the defect is available. Still, opportunities for error or opportunities for defect is not declared. Not declared means it is considered as 1. Not declared means it is considered as 1, or you can call it unknown. Unknown means assumption is 1, and based on the assumption, ZLT, ZST, Dpmo, Dpu, all are calculated.
Okay. Okay.
Is it clear to everyone in the meeting? All of you are with me?
Yes, sir.
Sir, yes, sir.
Great, great. So now situation 1. Now I am studying, inspecting 200 units, 200 samples. Out of, in every sample, there are 5 characteristics I am checking. Every sample, there are 5 characteristics I am checking. That means opportunity for error is known. After completing the inspection, I am able to understand that there are 6 defects. Totally, how many defects noticed? 6.
6.
I give an entry. Now what happened? I got TOFE. What is TOFE? Total
Opportunities for error.
opportunities for error. Can one of you explain how to get this 1000 manually?
Sample into opportunity for error.
Excellent. Sample into opportunities for error in each sample. 200 sample, and each sample 5 opportunities. So totally 1000 opportunity. Now defects per opportunity. How to calculate defect per opportunity? Can one of you tell me the manual formula? Defects divided by total opportunity. Defect is how many?
6.
Total opportunity is
1000.
1000. I think this is rounded. I think this got rounded, right? Don't worry about it. So this got rounded. Then probably we'll be able to get, okay. So don't worry about it. So that's how it is calculated, 0.01. You see here, now it is coming 6000 properly. So defects per million opportunities, 6000. Actually, this is rounded. Since there are only 2 decimals, it got rounded, it is showing 0.01. And ZLT is 2.51, ZST is 4.01. This is the template which all of you can use for discrete data situation.
Yes.
Now, one of you tell me what is discrete data, how to know the data is discrete. How to know? I need a quick answer because you are not now fresh. You are now seasoned Six Sigma professional. Discrete means
Countable data.
Countable data. Hope everything is clear, right? So now I want to familiarize all of you with this template, and then I'll take you through a PPT. Sigma level calculator. Now comes sigma level calculator. See here, Dpmo is known. Tell me a Dpmo value. When I type Dpmo, what is this populating? Is my screen fully visible or something is hiding?
It's fully visible, sir.
Fully visible, yeah. Tell me, what is, when I type Dpmo, what is populating?
Sigma level LT and sigma level ST.
Sigma LT and sigma ST is populated. ST is automatically populating. And then we have other things, defects per unit, and then Dpmo. If you know both, then also this will come. Let's say defects per unit is, let us say 65, is too high. Once I give defects per unit, this is too high. That is why, sigma levels have become minus infinity. So let me say, give a smaller value. Defects per unit is 5, then also it is negative. 1, okay. All right, so this will be helpful for that purpose. And then we have yield. Let me say I know the yield. Yield is 99.73%. When yield is 99.73%, then the corresponding sigma levels are here, right? Our yield is close to 99.999666%. This is the equivalent for Six Sigma, isn't it? 99.99996%. So what is it showing? It is showing 6 sigma short term, 4.5 long term. And now there is one more format where you can actually declare USL and LSL. Let me say USL is 200, LSL is 205. And process average is, let me say, 208.5. And process standard deviation, let me say this is 0.25. I give USL, LSL, process average, process standard deviation. I give enter. And now this is too worst process, I believe. The process is too worst, and that's why sigma levels have become negative, simply because the variation is far high. Let me reduce the variation and see what happens. This is also not sufficient. 0.00, let's say 0.05, I think. What happened?
Sir, the mean is outside LSL and USL.
That is the problem, right? Correct. You're right. You're right. I'm wrong. 202.5. Now it has become plus because this is too strong. So now let us say 0.25. Do not do 0.4 some value. Okay, whatever the actual value you put it, and this will come here. Your sigma levels are very high because the variation, since I kept the variation very low, when I increase the variation, you can see sigma levels going down. So far, good. All of you? All of
Yes.
you, please
Yes.
confirm.
Yes, sir. Yes, sir.
Yeah. Please note, all of you, this is not a lecture. Even your live sessions should not be treated as lecture. Should be treated as interactive, participative, right? And lecture already we have given in video. You can see in the app. And here this has to be participating, right? Now, going to this thing, CPCPK. In order to calculate CPCPK, what is required? The same thing. USL, LSL, mean and standard deviation. USL, LSL, mean and standard deviation, when you give, CPCPK will come. So this is what I want all of you to know. This is a very simple format. You can use this format or the format given by Dr. RK. Both will give same reading only. And see here, hundreds of data files I have shared now. You can use it for practice purpose. Clear? These data you can copy paste in Minitab and then you can practice. Is that okay to all of you? All the files you can see. Right.
Okay, sir.
Right. Now, there are 3 vendor data available. Each 120, right? Each 120. Suppose this 120 data, I want to calculate the mean and standard deviation. How do I calculate? How do I calculate mean in Excel? Can I go for this formula, average?
Yes, sir.
Average of from here to start or from start to end. Now I have taken. And now I close the bracket, enter. Can you all see the mean value getting populated here? What is the formula used? Formula used is,
5.7.
yeah, 5.713. Very good. Now formula used is average.
Average
Then you select your data.
below number.
Maximum number, whatever number. Once this is done, close the bracket. Once you do it once, simply you copy paste, the averages will come. All of you are clear how to calculate average?
Yes, sir.
Yes,
Okay,
it's a
sir.
very simple method. Everybody, you might be knowing it already. Now I want to calculate standard deviation also. Now standard deviation dot P means population, dot S means
Sample.
sample. So select that. And now, yes. Now once again, cover all the data. Close it. Enter. Now standard deviation has come. Same thing, you want to do it for second column and third column. This is how the mean and standard deviation can be calculated without manually doing the calculation. Alternate method is, what is the alternate method? Minitab. You all should be very good in using Excel as well as Minitab. Since Minitab is, software license is required, cost is involved. Those of you who could afford it, you have it, you can use Minitab. Otherwise, try to do the same thing in Excel. For that, the templates will be helpful. So the Minitab is getting opened. Let's get it loaded. All right. Yeah, I think Minitab is ready. So bank transaction time, on time, questionnaire, promotion, vendor. So let me copy this data. I want to go to Minitab now. Vendor A, vendor B, vendor C. Copied, Control C. Now my Minitab screen is visible.
Yes, sir. Yes, sir.
Yeah, visible. And now I copy pasted vendor A, vendor B, vendor C. Now what I want to do is, I want to go to stat. I want to go to, let's say, stat, basic stat, graphical summary. A, B, and C. Select all the three. At a time, I am plotting graphical summary. Can you see three graphs populating? Can you see three graphs populating? All of you, please confirm.
Yes, sir. Yes, sir. Yes, sir. One by one back.
Now, first graph, vendor C. Now, use your eyes, all of you, right? Keep your vision very clear. Look at this graph. What is the name of the graph?
Histogram.
This is histogram. And now in the histogram, x-axis is continuous data. If I replace the continuous data by discrete data or attribute data, an histogram will now be called as bar graph. The difference between histogram and bar graph is the x-axis. Now this is histogram. Looking at the histogram, tell me whether the data is normally distributed or not. Now you have to depend on your eye power. Listen, look at the graph carefully and tell me whether it looks in a bell shape to your eyes or not.
No.
Okay, Manikandan says no. How about others? Everybody is agreeing with the no?
No.
No, sir.
Yes,
No,
sir.
sir.
Somasundar says no. Roshan says yes. Ganesh,
No, sir. No, sir.
you are also saying no. Okay.
Yes, sir.
And Srikanda, Kolkanda, you don't want to participate? Srikanda,
No, sir. I want to
No.
tell me what is your view? Is it normally distributed or not? Just
No, sir. It is not normally distributed.
not normal, right?
Yes, sir.
Nageshwar?
Not normal.
Not
I find that it's normal. It's normal.
okay. If I ask about all of you, how do you behave? How do you behave in your workplace? Will you behave normally or abnormally?
Normally.
Normally.
Normally, all of us behave normally, isn't it?
Yes.
Yes,
You see
sir.
100 people, at least 95 people will behave normally. Only 5 people will have abnormal behavior. Is my statement correct or not?
Yes.
Yes, sir.
So don't doubt it too much. Those of you who said these are all abnormal, you should be able to tell the reason why it is abnormal. Right? Actually, the data is normally distributed.
Yes.
Data is normally distributed.
Normally distributed.
And if you are not able to differentiate what is normal and what is abnormal, that means, you have to check, probably not check your eye power. Probably you need to know actually what normally happens, right? This is quite normal. Can you see a bell, approximate bell? Isn't it? An approximate bell, slightly it is skewed. That's okay. There is no one is 100% perfect. So if you have problem in understanding whether the data is normal or not normal, Using the histogram, using your normal eye, you go for some hypothesis
P-value.
testing. That one of the hypothesis testing is already carried out here. Anderson-Darling normality test. Can you see all of you? Anderson-Darling normality test? Yes?
Yes, sir.
Yes.
Yes.
Now, what is the null hypothesis? Normally, normally all of us behave in the normal manner. Same way, data is considered to be normal. That is the null hypothesis. And look at the p-value. 0.4.
0.4.
That means
It's greater than 0.05.
it should be less than 0.05. Then only you can reject the null. Will you be able to reject the null? You can't reject the
No.
null. So accept the null. What is null? Data is normally distributed.
Distribute.
Clear? Done. Now second one. Now look at the graph and tell me, is this data normal?
Yeah, it is normal.
Normal. It's normal.
Yes,
Normal,
still
right?
it is normal.
It is normal. See, there is no one bar is also missing. Then also it is normal. Right? So p-value is a confirmation. And now third one. Third one is also normal and p-value is a confirmation. Look here. Very high p-value. Right? This is how it is. And now you can also look at now the other statistics given: mean, standard deviation, variance, skewness, kurtosis, so many things. And minimum, first quartile, median, third quartile, maximum. Look here, 95% confidence interval for mean. How much is the mean here? 5.71.
Mhm.
What is the upper confidence limit?
5.9.
5.95.
Lower confidence limit 5.47.
5.4.
You can also see the confidence limits here. Can you see here this kind of bar? This is lower confidence limit. How much it is? 5.47. This is upper confidence level. How much it is? 5.95.
9.5.
Now let me take one more graph. This is A. Now let us look at the B. A is 5.4 and 5.9. Now B. Look at the B. B is again mean is 6.09 and lower confidence limit is 5.85. Upper confidence limit is 6.34. Look at the C. Mean is 5.95. Lower confidence limit is 5.6, 6.2. Look here, the three means. One is 5.94. The other one is 6.09. The third one is 5.71. Now, which one is having a higher mean? A or B or C?
B.
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 Can I now say the B is better or B is bad based on the mean value? Because we always take decision using the mean, right? Now, mean is, what is this data? Transaction time, isn't it?
Yes.
Data is transaction time. In order to say better, you want a higher transaction time or you want a lower transaction time?
Lower transaction.
Lower transaction time. So who is having lower transaction time? A is having lower transaction. Now my only doubt is, can I now conclude that A is better than B and C? Now all of you have to answer to my question.
So for that, sir, we need to do hypothesis testing.
Yes. What testing we can go now?
ANOVA.
ANOVA. Because it is
Yes,
data is
ANOVA.
continuous.
Yes,
Because
Yes.
there are more than two groups. If there are two groups, we go for two sample T. Am I right? If there are two groups,
Yes,
we go for two sample T. For more than two groups, we go for ANOVA.
ANOVA.
For the simple reason that the error in the hypothesis testing can be retained at 5% level. Simple reason. That is the main reason why we are switching to ANOVA. If you want to do it in two sample T only, you have to do the test 3 times. Compare A and B, compare B and C, and compare C and A, isn't it?
Yes, sir.
If there are 3 teams playing a match, then how do you conduct the tournament? A and B will play the first match, B and C will play the second match, C and A will play the third match. And then we decide who is number one, who is number two, who is number three. But since you are doing the testing 3 times, error will be increasing. To avoid that, we are moving to ANOVA. So ANOVA, one-way ANOVA. Now, response data are in separate column. Where are the response? Column 1, column 2, column 3. Select. Now these options, you know, for ANOVA, the assumption is equal variance. You assume equal variance. If you want, you can test it, right? Assume equal variance, and then you give OK. Now I am giving OK. ANOVA is done. Have you seen this graph already? Vendor A, vendor B, vendor C in graphical summary I have shown. Am I right?
Yes, sir.
Yes.
Yes, sir.
What is this value? 5.4, 5.9. What is this? 5.7. What is this value? 5.8, 6.3. What is this? 6.09. This value 5.6, 6.1. This value is 5.945. Now my doubt is whether the 3 means are different or more or less same. Do you understand my question? Whether the 3 means are different or more or less same.
Yes.
More or less same means not same, but there is some difference, but I cannot consider that as a difference in real life. Am I correct?
Yes.
Yes, sir.
For example, you are earning 40,000 rupees. Your neighbor is earning 42,000 rupees. Will there be any difference in lifestyle? You are earning 40,000. Your neighbor is earning 42,000. Will there be a big difference in lifestyle?
No, sir. No, sir.
No.
More or less same lifestyle. Though you are gaining, you are getting a 2,000 rupees extra, it doesn't mean your lifestyle is better. No, more or less same. That is what is statistics. If you simply look at the 40,000 and 42,000, your thinking is mathematical. Now, being a Six Sigma expert, your thinking should be statistical. Imagine your neighbor's salary is 40,000 and your salary is 65,000. Will there be a difference in the lifestyle now?
Yes, there will
Yes,
be.
sir. Little bit.
Yes, sir.
The difference
There
is
will be
significant.
difference.
The difference is significant now.
Yes.
The difference is significant now. This is statistical. So when the see 40,000 to 65,000, even a common man can say, yes, sir, statistically it is different. But for smaller value like this 5.4 and 5.9 and all, you look at the confidence limits. Lower confidence limit, upper confidence limit. Upper confidence limit of A cross beyond the lower confidence limit of B. Am I right?
Yes, sir.
The same upper confidence limit of A goes beyond the lower confidence limit of C also. If this happens, you must conclude there is no statistical, A is not statistically different from B and C. Why? Because when
Confidence intervals are overlapping here.
correct, confidence intervals are overlapping. Simply because though the mean value is lower for A, still I don't consider A as better. Because at times A can have a mean value here. Am I right? What is the mean value here? 5.71. At the same instant, B can be at 5.8. Do you understand? What is the value of B here? Value of B here? 5.8.
5.8.
What is the value of A here? 5.9.
5.9.
Now who is better? A is better or B is better?
They are same.
Yeah, we should final overall conclusion is same. But in this situation, when A is here, when B is here, B seems to be better.
Yes.
So we want to avoid this kind of error happening. We are okay to tolerate a overlapping of 5%, but not more than that. We are okay to have an overlapping of 5%, not more than that. That means 5% of the instances our decision may go wrong. That is okay for me. But when it goes more than 5%, I don't want to take any risk. All of you understand the concept now?
Yes.
Yes, sir.
This is what your p value is directly telling you. You don't have to look at the error bar. We call it error bar actually, right? This is called error bar. This is called error of mean. How many of you know? This distance, center value. What is center value? The mean. What is this point? Upper confidence limit of mean, isn't it? The distance between the two is called as standard error of mean. You remember we talked about this sometime in the beginning. SE of mean. Am I right?
Yes, sir.
What is this SE of mean?
Basically, sir,
Standard
it
divided by
helps. It
square
helps
root
to
of
locate
sample number,
confidence
sample
limit.
size.
Right.
Very good. SE of mean is required to locate the confidence limit. And the formula for standard error of mean is standard deviation
Standard.
divided by square root of n. Where what
Yes,
is n? Your sample size.
Oh.
The right word is subgroup size. How many samples in our case? 120.
120.
We took 120 data, right? I think all of you understood, how the hypothesis testing is working. All the hypothesis testing, this is what you need to know. If you are comparing mean, compare whether the confidence limits or the confidence interval is overlapping or not. If it is overlapping to the tune of 5%, it is still okay for me. Neglecting overlapping area, still 95% of the area clearly confirms that A is different from B and C. I'll take a decision with that. But when the overlapping is more than 5%, I will not consider the difference as statistically significant. Simply because I will not be able to gain 95% confidence. And now I wanted to have one more complicated discussion with all of you. Imagine the overlapping area is 20%. Overlapping area is 20%. And now, can I make a statement that A is significantly better or different? Don't even say better. Significantly different from A and B. I want to make this statement. What is the overlapping area I said?
20%.
20%. So when can I say this statement?
The overlapping area is less than 5%.
Yes, 80% confidence. Yes, sir.
At 80% confidence level, I will say that A is significantly different from A and B. But I have clearly declared, hey gentlemen, I am only 80% confident. That means 20% of the instances, my statement may not save you. All of you are with me on the statement?
Yes.
Yes.
That's
Sir.
all. And now whether you are using p-value or you are looking at the error bar is nothing but the confidence interval. You can have confidence interval for anything. You can have confidence interval for mean. You can have confidence interval for median. You can have confidence interval for standard deviation also. See here, this is all available here. Ultimately, we are only checking whether the confidence intervals are overlapping or not. All right, so far good. So I stop sharing the screen and I want you to take you through, yes, a PPT. How many of you subscribe to my channel? All of you?
Yes, sir. I have subscribed, sir.
Yeah, please, all of
Get
you.
to subscribe.
Yeah, subscribe. So I wanted to post a lot of analytical questions in the channel, which will be helpful for your exam as well as, and after completion of the exam also, it is good to go through all those questions. So that is there. Yeah.
Hello friends,
Oh
in
God,
this video we are going to see
it is playing the narration.
about
I will stop the narration because I am there to do the job. So, all right. So we'll see a few questions. See here, Some data is available. You are asked to find out the mean and standard deviation. Tell me, will you be able to do it or not?
Yes, sir.
Definitely you will be able to do it, right? So you have the data. Just find out the mean, find out the standard deviation and look for the answer, closer answer. Always know one answer is the best answer, right? So out of the four, which is too close to the real answer, that one you should pick. Now, can you answer this question? And along with the justification, what is the area contained within plus or minus 3 standard deviation from the center of a normal curve?
99.73.
99, yes.
99.73%.
Very good. So what are these points called? Plus or minus 3 standard deviation. What is the name of those points?
Six
Six
sigma.
sigma.
Control limits.
Yes, sir. Control limit. Yes. Yes, sir.
Right side is
Upper
upper
control and
control
lower
limit,
control.
left side is lower control limit, right?
Yes, yes. Yes, sir.
Which of the following is the correct formula for Dpmo? There are several formula available. We did an experiment and there is one formula here, row number 2, defects per opportunity multiplied by 1 million,
Just
which is defects per million opportunity. Now, there is a problem. The dimension of a particular part should be between 225 and 230. What is this 225?
Upper specification limit.
upper specification and lower
Lower
specification
specification
limit.
limit.
And upper
The
specification.
reverse. This is lower specification 225.
Oh, sorry.
This is upper
Upper
specification
specification
230.
Oh.
An operator collected a sample of 100 parts and he found that process average is 226 and variance is 0.4. Now you are asked to find out is that LT and is that ST. You all know, we have seen this Excel sheet, right? And where you see here, mean is available, standard deviation available, USL, LSL is available. Do you think all the four are available with you? Mean, standard deviation, USL, LSL?
Yes, sir.
We have only variance.
Sir,
Yes, yes.
standard deviation is a square root of variance.
Very good, beautiful. Standard deviation is square root of variance. We know that. Convert it,
Yes.
apply it, you will get Dpmo, you will get ZLT, you will get ZST. See, the tougher calculations is getting easier. You can even crack any international examination if you still wanted to go for any examination. With these templates, you can handle problems very easily and in no time you get the answers, right? And this will be helpful in your project also. This problem I already explained. I'm not going to explain it again. Only tell me which situation it fits into. 3,000 dishes are inspected, 60 are defective. Situation 1, situation 2 or situation 3?
Situation 3.
Situation 3, right? Situation 1 is for defects, 2 also for defect, 3 is for defective. All right. So we move on. While editing orders over the phone representative mandatorily checks for 6 field. That means opportunity for error is 6. The quality team sampled 200 calls. Sample size is 200. And overall, they found 5 defects. When I type these 3 values, all these values will populate. What is the question? What is ZLT? What is ZLT? 2.64. So we are able to conveniently solve the problem. And now, for a process CP equal to 0.94, CPK equal to 0.33. Clearly, the process is not capable. When do we say the process is capable? If CPK is more than 1.66.
1.67.
67. 66 or 67, both are accepted. And now it is not capable. But now what are you supposed to do? Practically, what are you supposed to do? You should know the industry, you should know the process, you should know the problem. But statistically, what are you supposed to do? Move the mean close to target. Why should I make this statement, move the mean close to target? One of you would like to answer this? Why?
Because CPK determines the mean. So it's 0.33, it's away from the
Very
mean.
good. Good point. Slight correction. Since CPK is different from CP. Since CPK is different from CP, it's a clear indication that your process is shifted. So you have to move the process mean closer to the target. This is statistically offering solution. How you will move the mean? that you have to do a lot. Suppose your 3-month sugar level is, let us say 7.5. They call it HB1AC, am I right?
Yes.
Sugar level is 7.5. You have to move the 7.5 to 5.5. Now you have become non-diabetic, isn't it?
Yes.
How will you move that mean? Can you push it with some tool? No. You have to change your lifestyle, your daily
Yes,
routine,
yes.
your food habit. So without practically knowing what is the problem and what is the situation, what is the process, we can't offer the, what you call, the domain specific solution. But statistically, the solution is this. All of you understand what I'm speaking now? If the experts, subject matter experts, domain experts work correctly, that will move the mean towards the target. Am I correct or not?
Yes, sir.
If the
Yes.
doctor is giving you the correct advice, if the patient is following the advice correctly, definitely the mean will move towards the target. Your HB1AC sugar level will definitely come down. If those of you have any diabetes problem, you can try. You can even publish your findings in a paper. A lot of papers are available for your reference. And moreover, reduce variation. Why are we saying reduce variation? Why are we
Because
saying
CP is less than 1.
Because
CP is less than 1.66?
Yes.
Because our requirement is 1.66. So that is not happening. If CP is more than 1.66, only CP, CPK are different. I will only tell the first statement. I'll avoid telling the second statement. All of you understand how to statistically solve a problem. Clear?
Yes, sir.
yes.
Now, data being used in the initial setup of a process are assumed to have a normal distribution. So data is assumed to have a normal distribution. Nominal is set at the center. Nominal is set at the center. That means process center and customer target are same. Specification limits are set at plus or minus 3 sigma. Then what will be the value of CPK? Do you
Yes,
like to answer this question?
At that time, CPK and CP both will be equal.
Beautiful observation. At that time, CPK and CP will be, both will be equal. But what will be the exact value of CPK?
One.
Unknown.
Why it is 1? Why it is 1?
Because
The
the
control
ratio
limits are
between
equal
the
to
variation
specification
is
limits.
same.
Control limits are overlapping with the specification limit. Close your eyes and say CPK equal to 1. Clear?
Yes, sir.
Yes,
What is the exact time now?
49.
850.
8:50 only. So we'll see a few more questions then up to 9 o'clock. Significance level in a sampling study is fixed as 1%.
Mhm.
What will be the confidence level of this study?
99.
99%.
Now, what are the other possible statement? Giving the same meaning. Level of significance, 1%
Is
means
5%. Okay. 1% means 99% is confidence.
very good.
Interval level.
99% confidence level.
If 5% is there, then if 5% is there, then 95% will be the correct
90%.
answer. Right?
Very good, very good. The 1% is the permissible overlapping allowed. Isn't it?
Acceptable.
Permissible
Yes, sir.
overlapping allowed. And but however, 99% confidence level is the target now, because we want the level of significance to be 1%. Very good. ABC company wants to know whether the proportion of customer who return a survey increases by providing an incentive such as a promotional discount coupon on completion of the survey. Percentage response with the coupon is to be compared with the percentage response without coupon. What is the appropriate test? So I do a survey. When I send survey email to 1,000 people, how many people respond to my survey? That is called response rate. Am I right?
Yes.
I send my survey form to 1,000 people. Hardly 65 people responded. So what is the response rate?
6.5.
6.5%. And now I think I feel that the response is very poor. So I am in the same email, I'm telling them that if you submit the survey, if you complete the survey, you will get a discount coupon, Amazon discount coupon. You will get 500 rupees worth Amazon discount coupon. Now what happened? What will happen to the response rate?
Increase.
It will increase from 6.5% to, let us say, 40% or 50%. Now my doubt is whether the idea of giving discount coupon is really impacting the response rate or not. It is impacting because 6.5 to 40% is a significant improvement, isn't it?
Yes, sir.
Yes, sir.
What is this hypothesis testing called? You are comparing 6.5% and 40%. What is the hypothesis testing here?
Proportion test.
Two proportion test.
Why it is two proportion?
Because we are
Because
comparing
the
the
data is
percentage.
discrete.
Data is discrete. The 6.5% what we talk about is, yeah, proportion. 65 out of the 1,000 is 6.5%. 40 out of 1,000 is 45%. So 65 out of 1,000 means it's a proportion. We should know what are we comparing statistically. Is it a proportion we compare or is it an average we compare? For the same situation, if I compare the average, let us say the average time taken to fill up the response form, to complete the survey, how much time people are taking. Now, the time to fill up the form is the criteria for me. I have two different forms, form A, form B. Whether form A takes more time or form B takes more time. This is my doubt. Now, which hypothesis testing will go well now?
Two sample
Sample
t-test.
t-test.
Two sample test. Very good, right? You are with me. Fantastic. So this is how you must see hypothesis testing happens every day in our life. But unknowingly we do it. When the difference is too high, you don't even require a p-value. You don't require a p-value. Your child is studying. Your child, in mathematics, your child gets only 60 mark. Now you appointed a tuition teacher. Now what happened? The mark rises from 60 to 90. Do you think the tuition is helping your child? Yes or no?
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
Definitely helping. So what is the hypothesis testing you have done now? Before tuition, after tuition, isn't it?
Yes.
The test mark, test performance before tuition, test performance after tuition. What is this?
Two sample t-test.
Two proportions.
Two sample t-test or proportion test. Now what is test mark? Test mark, is it continuous or discrete?
Yes, it's a discrete value. Two proportion test.
Test mark is not discrete. It is made discrete. The numbers are whole, but you can even give fractions. Am I correct?
Yes, sir.
So test marks are continuous data. So it is two sample t-test. All of you understand?
Not
Yes, sir.
getting, sir, actually.
But particularly going deeper, if you go for a paired t-test,
Yes, sir.
it will be much better. Why? Because your child is same.
Okay.
Before tuition is also your child gave the exam. After tuition also it is your child giving the exam. So the test, since the the subject remains same, it is called paired t-test. Clear?
Yes, sir.
Great.
So what is that, sir, Bartlett test?
Bartlett test is a test of variance. See, we take decision using statistics, right?
Yes, sir.
Statistics can be average, statistics can be standard deviation, statistics can be proportion, statistics can be variance, isn't it? Statistics can be, sum of squares, statistics can be range, statistics can be median. Since there are too many statistics are there, you have to give a unique name to every hypothesis testing. How many trainers you have in our program?
5.
5 program. And every trainer has got a name, isn't it?
Yes, sir.
I simply call everyone as a trainer, then you will not be able to, understand clearly. So, since there are so many statistics are available and different hypothesis testing procedures are created, and each procedure is given a specific name. And Bartlett test is the name given when you compare the variance for more than two groups. Clear?
Yes, sir.
And this comes by experience, right? You don't have to really memorize everything. For example, none of you know the trainer's name before joining the program. Am I correct?
Yes, sir.
But after joining the program, you are used to interact with us. You know my name, you know Dr. RK's name, you know Vinod Shankar, now in the future somebody calls, you will be able to refer our names very easily. So don't really get afraid of seeing all these names. And there will be a time where some testing needs to be performed. At that time, if you know this is the suitable test, then apply it and then you will never forget, right? At least you must use the test once. And now for a particular task, if the assumption is that TAT means turnaround time, is a function of region, maybe France, Denmark, and UK, whatever. Then the hypothesis test which can be used to ascertain the same. Would you like to answer this?
ANOVA.
Yes, ANOVA.
Why ANOVA?
We are
Because
comparing
turnaround time
three
is continuous data, right? And three different groups are there, FR, DE, and UK.
Very good. Continuous data, three different groups. And so ANOVA. ANOVA simply test whether the average turnaround time is different in one of the area. Is different in one of the area. The decision is taken on the average. Decision is taken on the average. And in the process, we use variance. That is why ANOVA. VA means analysis of variance.
Variance.
We make use of the variance to understand whether the average is different or not. Right? So, though we call it ANOVA, the decision is on the average. Now, a department want to migrate to a new tool which claims to reduce the cycle time for a particular process. What would be the correct null hypothesis statement? There are 4 statements given here. Which will be a correct hypothesis statement here? Any idea? The answer is already given in red color, but then also you should be able to justify. Why it is the last option? Why not the first 3?
Sir, last option is only showing the statement of equality. Therefore,
Very good. Statement of equality happens only with the last 2. So first 2 definitely wrong. This cannot be null.
Yes, sir.
And now in the last 2, we have the notation, right? H0 and HA.
Okay.
So H0 is for null, HA we generally don't use. HA represents alternate. So the answer is this. Otherwise, this is same. Look at the way the statement is drafted. Cycle time of process with the new tool is equal to cycle time of process with the old tool. But what is the objective of the researcher? To prove that the new tool reduces the cycle time. Am I right?
Yes, sir.
That is your research hypothesis. That is your alternate hypothesis. You can check, you can try to validate the alternate hypothesis only after getting the null hypothesis rejected. Clear? Only after getting the null hypothesis rejected, you can start investigation with your alternate hypothesis. So the decision, whatever we are taking in hypothesis testing, is on the null hypothesis only. In any hypothesis testing, the decision is taken on the null only. What decision you take? You either reject the null or you don't reject the null. If I reject the null, does it mean alternate is valid? Come on.
Yes, sir. If we are rejecting null, then alternate hypothesis will be accepted.
Right. Suppose somebody
subject
says, Roshan is very good person. Roshan is very, very good person. right? And now other person is not agreeing to it. Does it mean Roshan is very bad? I'm only not agreeing, isn't it? Because I do not know. I don't have any I don't want to agree with it. So rejecting the null not necessarily leads to accepting the alternate. All of you understand? Rejecting the null not necessarily leads to accepting the alternate. But you can, because chances will be more. Because chances will be more. But if you still wanted to have confidence in accepting the null, you can further investigate. Nobody is going to stop you. Clear?
Yes, sir.
Yes.
Indian team and Pakistan team are playing. Indian team and Pakistan team are playing. Now, what is the null hypothesis? The Indian team performance and Pakistan team performance
Will be
are same.
Indian team performance is equal to Pakistan. Yes, sir. Same.
Pakistan team performance.
Yes.
Suppose I reject the null. Does it mean Indian team is better?
No.
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 I have to play a match.
Yes, sir.
So rejecting that null not necessarily lead to accepting the alternate, isn't it? You wanted to prove Indian team is better than Pakistan. So your initial study revealed that the performances are not same. Performances are not same means you are rejecting the null. But in order to accept, yes, Indian team is really better, we actually conduct a match and the trophy is given. Clear to all of you?
Yes, sir.
So this is the basic concept, right? So which test will you conduct to compare variance of more than two groups? We already spoke.
Yes,
This is
but-
botnet.
Yes.
And how many questions are there? Okay, this question alone we'll see. But this is again, this requires data. So probably this I will deal in the next class. Actually, here the question is, it's a big thing. This is talking about turnaround time in a diagnostic laboratory in a hospital. And there are 4 laboratory, right? You can see here, 4 laboratory. And is there any specific laboratory completes the diagnosis in a lesser turnaround time? So you wanted to understand for at 5% level of significance, whether there is evidence exists to say that one of the laboratory is the turnaround time of one of the laboratory is significantly different from the others. That is the question. So what you need to do, you should actually get this data file. The data file is available in our Excel sheet, isn't it? You copy paste the Excel sheet and conduct the appropriate hypothesis testing and check the p value. If the p value is less than 5%, then there is significant difference. If p value is more than 5%, there is no significant difference. Or answer could be the other two. But in this case, the answer will be this two. If you want, I will just show that problem and then close the session. Please tell me what is the time now so that
9:05.
Oh, 9:05 already. So can we just finish off this question and then leave? Shall I do it? Turnaround time. Not required.
Yes, sir, we can finish it.
Yeah. The file is available. So what will I do is, I will only show the file. So share the mini tab. So I'm sharing the mini tab. And before that, the turnaround time for laboratory. So I'm just copying it. See. So I'm in the Minitab screen now. I'm going to the worksheet. Let me place the word data. All of you can see my worksheet, laboratory 1, laboratory 2, lab 3, and lab 4 data.
Yes, sir.
Please confirm, right? So now what is the hypothesis testing I should do now?
ANOVA.
Very good, beautiful. Go to stat, go to ANOVA, and then go to stack
One way.
ANOVA, one-way ANOVA. And response data are in separate column. What are the columns I should choose? C5, C6, C7, C8. And I have to select. And for ANOVA, the assumption is variances are equal,
Equal variance.
right? So variances are equal, okay. Again, okay. Now testing is done. Can you see the mean value and the confidence limits, mean value and the confidence limit, mean value and the confidence limit, mean value and the confidence limit. Can you see this confidence limit not at all overlapping with any of the confidence limit? Please confirm.
Yes, sir.
Yes.
4 is significantly different from all the 3. 3 is also significantly different from the remaining 3. Am I right?
Yes,
Yes.
sir.
Yes.
Yes, sir.
Now compare between 1 and 2. Tell me, is that 1 is significantly different from 2 or 2 is significantly
sir.
different from 1?
No, sir.
If you compare
No
between
difference,
1 and if you compare between 1 and 2, what is your hypothesis testing?
One.
Both are
There is
same.
no
Sample,
significant
two sample
difference.
t-test.
2 sample t-test, right? And if you compare all the 4 at a time, then it is ANOVA. Very good.
Unknown.
I think your understanding is now much better than what you are before learning all these modules. Maybe at the time of learning, you could have found some difficulty to cope up with the class and all those things because the concept is little new as well as tough. But if you start practicing all these things with these kind of some case studies, definitely things will be much easier. And that too with the tools we are providing you, like the Excel template and the Minitab or any other software which you are familiar with using, your job becomes much easier. All right. Is this class helpful today?
Yes, sir. Also, it's very useful.
Very good. So all the best. I will also be posting similar such sessions in my YouTube channel. Those of you who have not subscribed, please subscribe to the channel and so that you get access to it. And this is these kind of things will be additional learning. So you will not see it in the mobile app. You don't get it in the app. You will get it only in the YouTube channel. Right? Okay. Thank you all. Bye-bye.
Okay, sir.
Thank you, sir.